Today's webinar is an overview of the Wattics solution specifically targeted for institutes of higher education. My name is John Heinz. I'm our VP of Strategic Accounts here at EnergyCAP. Our solutions, which is rooted in EnergyCAP, provide value to organizations. So the main mission of our company is to allow you to input and enter energy and sustainability data and then get value out. And value comes in a lot of shapes and sizes. There's value in energy and sustainability and carbon and real-time data. So our mission has been to develop energy and sustainability ERP, which is enterprise level financial grade data that is the single source of truth for all of your valuable energy and sustainability information. The framework that we've created in this energy and sustainability ERP, it's a framework that provides value to you. There's three different solutions that are part of this framework. EnergyCAP, which is centered on utility bill information and monthly bill tracking and reporting. Wattics, which is the topic at hand today, which is time series data tracking, interval data, real-time metering, and real-time analytics. And then we've also now introduced Carbon Hub, which is our greenhouse gas and sustainability reporting application. All three of these work together. They can share data and provide value to you in a lot of different ways. We also, as an umbrella to all of the applications, have Capture Services, which is our service to provide data processing and bill entry for use within each application. We are focused, though, on the Wattics application and real-time data tracking. So what Wattics provides is a lot of value, very specifically target to higher education. A huge value stream is the ability to collect and connect data and bring in data to the application from hardware and metering sources. We found by serving universities and institutes of higher education for over 40 years that most of you have installed meters and hardware that you manage and that are already within buildings and connected to zones in buildings and to equipment. And you're on a mission for finding appropriate tools that can connect to these devices and then give value out. Well, that's where Wattics comes into play. So Wattics can connect to devices themselves or connect to metering systems if you already have some data historians in place that are connected to meters in the field and storing reads. All of that data can be imported and connected into Wattics, and then Wattics provides analytics on that data. One of the huge value streams for campuses is then the ability to backfill and replace bad and missing data. So not only is it analyzing all the meter reads that are coming in, but also providing some tools that we'll cover today to backfill and replace any bad or missing data. If a meter's offline and you need to estimate reads, but you still want, the profiles and the 15-minute or 5-minute data, the application allows you to backfill that data smartly so you don't have missing or bad data. That then is really strategic if you are connecting Wattics into EnergyCAP. So as interval data is flowing from Wattics into EnergyCAP, because you need to create a bill with your interval data, you have really accurate financial grade interval data, of which you can then create monthly bills and chargeback bills from that great data. So it replaces the need to do monthly estimations. A lot of other value streams with Wattics. Wattics functions as another team member. It's your ears and eyes. It helps you by analyzing your data 24/7. I was talking to one of our clients, university, last week, in fact, where you know, our contact there had said, hey, I'm really struggling here. I'm a bit of a one-man operation where I have to monitor meter reads, get those into, you know, they're using EnergyCAP, get the data into EnergyCAP, and then make sense of the data, create bills, and we constantly find meters that are offline. We also find spikes in data, and it takes a lot of effort to go back and look through the data. Wattics can do all of those analytics for you automatically. So it functions as a whole nother team member by constantly monitoring your data, allowing you to in alerting and alarming any types of problems as those problems occur in real time. So then you can start to address those immediately and not have to wait for after the fact when you're starting to do your billing and looking at data after the fact. So some real value in time savings that, you know, tools within the application that you can use. But it can do so much more. It can spot problems with equipment cycling on and off. It can identify scheduling when systems are turning on. What time of day are they turning on? Are they, you know, turning on too early? Are they setting back too late in the afternoon? Some really nice tools I'll cover to run some what if scenarios, even if you want to see what you might save if you can go deeper, do deeper setbacks during off-peak hours. It can help find peak demand issues. Again, talking to another campus where they really have an issue with some of their rates with their utilities for demand charges, where when they are setting their demand charges for the year, you know, there's a certain window of time that the utility is setting demand rates, and they really need to keep management of demand loads so they don't get hit with a high spike, and then that then sets their rate for the year. So a lot of different value areas that the Wattics tool will help you in managing scheduling and managing system setbacks and monitoring various pieces of equipment and making changes within your buildings. Okay, so let's talk very specifically about the application itself. The capabilities within Wattics allow you to capture data in real time from any source and any type of device. It then lets you monitor that data and detect problems, outliers, and will alert and alarm for any of those problems, and then provides numbers of robust analytics and reporting functionality to let you drill into the data, to start running what if scenarios, make decisions, do M&V, and a whole lot more. From a data integration standpoint, Wattics can connect to devices. It can connect through file exchanges, through API calls, a lot of different ways to get data into the system. So there's a lot of documentation we have that we can provide that shows existing hardware and meters and sensors that the system's already connected to that are plug and play ready. Also ongoing, just about every day, we're working on integrations through file exchanges and API calls with users to connect to systems that they're managing in-house that do some level of meter data collection, and then that data is flowing into the Wattics application. So a lot of different ways to get data in. And then some high-level functionality within the Wattics application. Providing real-time alerts and alarms, machine learning algorithms that let you trend in expected load compared to your actual. So it's using historical data to estimate what your reading should be and the expected patterns. IP or ISO and IPMVP compliant M&V and measurement and verification of savings. Heat mapping, you can create formulas. You can dashboard and do rate analysis and do scheduling optimization and really a whole lot more. When we get into the demo, you'll see some of this, but realize Wattics is a very robust application that lets you analyze your real-time data. Okay, so let's jump into the application. Okay, so we're now within Wattics. So web-based application, just launch a browser and you can log in. When you have a license or subscribe to Wattics, it's for an unlimited number of users, and you can set user permissions and settings so your users can access parts of the program you want to give them access to, and then allows them use some flexibility of what all they can do once they're in the application. But what we're at here is just one of the many home screens that allows you to look at various values in real time. So you can set some widgets to track data in real time as it's coming in. And then down below, it will show notifications for any types of alarms or alerts that it wants to send you to and draw attention to any problems. More to come on that in a minute. So what is Wattics tracking? Well, let's first start by talking about the data that it's tracking. So you'll notice throughout Wattics, over to the left, you have a tree structure where you can put your meters and then link them to buildings and then organizational structures. In this particular example, I have an HVAC unit that I'm monitoring, and then below it, it's the subcomponents of the HVAC. So if you have those subcomponents monitored, you can actually nest sub-meters within a master meter for various analytics and reporting. In the middle, throughout the Wattics application, there's the charts and graphs and analytics that you're looking at. And then over to the right, there's filtering options. So as it stands right now, I'm looking at, I'll go to today, which is February 7th. I can look at the real-time data as it's been coming in for everything that is part of my HVAC operation within this building. So here I can look at the real-time data coming in. You can find things like the 15-minute average peak for the time period you select, or the 30-minute average. I'm looking at daily data here. I might instead want to look at weekly data. So here I'm looking at one of the weeks, and again, it's finding the peak period for the week. So you have the ability to track all this real-time data, view it a lot of different ways as it's coming in. You'll also notice whenever you see any of these charts, this menu screen, this allows me to download images. I can also download the raw data in a flat file for any of these charts that I build. So when I get later on into some more of the advanced profiling and analytics, you can build whatever you need to from a viewing standpoint and then download the raw data if you just want to get it into Excel or a flat file format for use elsewhere. Okay, so this is raw data coming in. Wattics can track, really any commodity. So you have electric, gas, water, also have the ability to track steam and chilled water. So any of that type of data that's coming in from your submeters and your sensors and your systems can be brought into the system. It can track solar, really anything you're monitoring from a time series standpoint. The other use case is bringing in temperature. So instead of consumption, it might be temperature reads as part of a chilled water loop where you can bring in temperature, and then I'll show some functions to do calculated points that can do calculations like delta T and looking at the differences in temperature or any other type of calculation you might need to create. So as this raw data is coming in, this data then is being scrutinized and run against alarms and alerts. So what are these? There are 3 types of alarms that can be triggered within the application. The first one is an offline notification. So what this allows you to do is you can pick any point. So let's say my chilled water point I'm monitoring at a building. I can then set up an alert to email me after a certain time period if I'm not receiving readings. This is really helpful to alert your team if a meter goes offline or there's a connectivity issue to the meter, or even if you're doing file exchanges for some reason, the automation that would get set up to import reads is not triggering. This allows me then to say, what's the time period? Maybe if I haven't received a read in 12 hours, I now want this to notify me that a meter's offline. So really helpful to diagnose issues before you run into this, period where you have days that go by without reads. So that's one type of notification and alarm, offline. The second one is a custom detection. So you can go to any point within the system, and maybe I, want to go to my Steam and say, if a threshold is met, if I go above X number of pounds or go below X number of pounds within my readings, I want an alarm to be triggered and a notification to be sent to me. I can identify what those thresholds are, and then I can decide when do I want to be alerted. So I can pick time periods, I can pick days of the week. Like maybe I don't want to be notified over the weekend on certain alarms because I'm trying to take some time off. You might have other alarms you only want on the weekends if it's a potential water leak or something along those lines. So you identify when you want to be notified and then how. Do you want to be notified on a dashboard? Do you want to be texted, emailed? And you can set up email recipients for this to notify more than one user. A critical point here, I think that's very noteworthy, is there's APIs. This whole platform is built on APIs. And I've been in talks with some of our campus users that have said, hey, like these notifications are great, but could we tie this into a work order system where we already have, work orders set up to go out to the field? And really the answer is yes, because of the fact that this is built on APIs. We could work with you on doing some type of integration to those asset management or work order systems if you wanted to do something like that. I think that is a good use of a system integration where this can detect the problem, but you might want to have another system actually send someone to the field to go check a meter. So wanted to mention that. I think that very noteworthy for our campus users. So once we set up this detection, we can save it, and then the system, anytime Steam reads are coming in, if it meets this threshold, you'll get a notification. And then the last one is a detection based on what we call Sentinel. So for any one of these points, you can set up an alert to alert you when it exceeds or goes above or below what's called a Sentinel view of your data. So the question is, what's Sentinel? Sentinel is the machine learning capabilities of the system. And I'm going to go to this meter right here. I think this is just a pretty standard interval data profile. So what this is, it's a machine learned capability that predicts what the profile should be for every given point that is in the system, and then trends your actual consumption versus that expected value. So this green bar is the expected load. This is the Sentinel. It's saying, for this particular meter, typically turns on around 5 in the morning, peaks out up here, and then starts its shutdown anywhere from like 10 to noon, at least starts its setback, and then, kind of remains about flat for the rest of the evening. So it's saying that is the typical profile based on history, based on days of the week, and certain other algorithms. And then we're trending in black what the actual load is compared to this expected load. So this, you can go through any one of these points, and every point's a little different. So this floor, which is part of a building, is a much different profile. And so the Sentinel view for this looks differently. So you can have the system flag when a reading goes above or below the Sentinel. It's a very nice way for the system to, create what the expected load is, and then you don't have to guess what the appropriate thresholds are. It'll just create that for you, and then you can alert against it. And how this can look in practice is, if I go back to my home screen, we have all of these notifications here that a few days ago, I was alerted that said there's a problem with one of my points. If I click on this, what this is telling me is that an air handler unit has consumed 73% less than usual. So in this case, it's like, well, it went well below the Sentinel, and it provides some other details. So this is the type of view you could get in a text message or here on the notification screen. And if I wanted to see where this displayed on the Sentinel view, I can click on that and you can see what's going on. This is the typical trend for this air handler unit. For some reason, January 23rd, it just didn't function. The air handler unit just was not working properly, it looks like. And so that's why I have all these notifications, because it actually wasn't working. So even for this first notification, we could have sent this to an engineer or just someone assigned to this, and then they could go out and take a look and see what's going on. So that's the use of this Sentinel matched up with the notifications and alarms. Okay, other capabilities. There are a ton of analytics built into this. What's really exciting about the analytics is they're just point and click and off we go. If I want to click on any point at any building, I can just start clicking and it'll just add to the chart. And then over to the right, I could say, well, maybe I want to look at a daily view of this data. This is February 6th. This is 3 points, one stacked on top of one another. I could aggregate them and look at them, as a total stacked up with one another. And so this is showing the total for every day and how each one of these stacks up compared to a total. It's also on the fly giving my total roll up for any time period or objects that I'm stacking on one of on top of one another. So I could see if I just wanted to look at the bar area, I could see what the total use is for any given day, week, month, whatever the time period is. You can compare day to day, week to week against one another, and just do a lot of comparisons. Again, it's just point and click and off you go. The system's tracking use and demand. There's a tariff engine, which also allows you to apply cost and CO2 calculations. So for any one of your objects you're tracking, you can apply cost to it. So, and you can apply time of use rates. Because you're tracking interval data, you can track time of use rates, and then it'll give you what your real-time cost is. Again, if I go to it, let's say a daily profile, this is showing every 5 minutes what my cost is, because it's taking the rate that I built, apply against the consumption, and now I get my 5-minute cost, and then it's rolling it up. In this case, I'm looking at a daily view. I could roll that up to a monthly view, and it gives me what the total cost is based on, again, that math of use times rate for the month. We can also look at our CO2 emissions. Similarly, it's saying what's your unit per CO2 equivalent, and then it's providing your carbon footprint in real time, again, daily, hourly, every 5 minute. Some of you might not need it that granular, but it will show what your 5-minute CO2 emission is in real time. Some of that might be nice for you for dashboarding. You need to create a dashboard for student groups, create a dashboard, real-time CO2 emissions, and then save it. So speaking of dashboards, let's say I want this to be part of a dashboard because I want my students or faculty to see what my real-time, every 5-minute CO2 emissions are. Really easy to add this. I just created it. I can then click this button and then I can save it. So I could call this real-time CO2 trend. I can then say, do I want this to be a fixed period? Do I want it for Jan 6th, or do I want it rolling, meaning it's, the view's moving with me through time? I could share this with others. Once I save that, it now goes to one of my dashboards. And so this is a dashboard that I just added this to, where it's showing all those types of views. The great part about Wattics is you just build it very easily the way I just showed, and then you can save it. So down here's my real-time CO2 emissions, literally real time through today. And then I can share this with others. So Wattics provides a dashboard link that I can then embed in web pages, share this with team members or student groups, and then they have access to all of this. Again, the menu, I could download the data. So if you have student groups that say, hey, I don't even want the charts, I want raw data, you could still give them these charts and then they can download the data. So if they wanted this CO2 real-time data, they could download it really easily. So great ways to show your performance and to get the data out there. So what else can Wattics do? If you have, some points that you then want to alert a team member about, like let's say this point right here, like, yeah, I just want to send this to one of my field techs to look into because it was a high spike. Maybe it's a demand read. In this case, it's use, but I want to send this because the system's peaking out higher than what I anticipated. Well, down below, I can add remarks to this, and I can select time periods that I want to add a remark to. So let's just say, for this day at 5 o'clock to 7, I want to add a remark, and I can tag a user and say, hey, Adam Wetzel, maybe look into this for this time period, and then I can save it. So now Adam just got a notification that he needs to look into this. And then what we can do is overlay those time periods on top of this chart. So very actionable note-taking and alert your users, of notes. He can then come in here, reply, add additional notes, and resolve issues. Another really powerful capability within the system is the ability to create formula meters. So you have interval data flowing. You can then, here, I'll show you an example. Like, let's say you need to do an aggregate. In this case, I have electricity that I bought from the grid. I'm also generating PV. I can then create a formula that allows me to say, well, take this meter, add this, and then create the interval data trend and sentinel and alarms based on the math. So think some of your chilled water, advanced calculations. You can build these right into the system, where all you have to do is select a point and then start adding math to it. Division, subtraction, multiplication, all those kind of things. And then once you add these points, let's say I want to add these two together, you get some visuals down below, and then I can create a new point based on the formula. Okay, two more very advanced capabilities I want to show is one of them is heat mapping and the ability to do schedule optimization. So this part of the application will show a heat map where the dark squares, the dark rectangles are showing high peaks, and the lighter green are showing low peaks of usage. So I can see that pretty regularly we're turning systems on at this time and then starting to peak out and starting system shutdown around noon. And then some days I have deeper setbacks than others and higher use than others. So this is at least showing what the heat map looks like. You can then go in and say, well, maybe every day Sunday, for higher ed, you might say, well, Saturday and Sunday, I want to do some deeper setbacks. Maybe I want to reduce everything 70%, maybe 60, 70%, because it's unoccupied generally those days. So you can save a schedule, and then it'll tell you how much you would save percent or total KWH or total cost wise if you can make those scheduling adjustments. And it shows the profile down here for the heat map. So really nice functionality to allow you to run some what if scenarios if you need to do deeper setbacks. You can then go to the building as a whole and say, for all the modifications I want to make, what would be my savings by meter and in a cost table. So it also will show it from a usage standpoint. So some really nice tools to show you times of day and days of the week when you're using the most, and then run some what ifs if you can reduce during some of those off-peak times. The last thing I'll go over is the measurement and verification of savings. So if you're running some of those what ifs, you can then start to track actual savings numbers once you start implementing projects. This application does both IPMVP option B and option C protocols. And a walkthrough one of these projects looks like this, where there's a tool that lets you describe what the project is. So in this case, it's part of a factory where they're making changes to an piece of equipment. We're using option B and providing cost metrics. And then you can describe the project. So this allows you to organize what the project is and communicate it. You can then communicate what the ECM or energy conservation measure is. And then you set your base period. So this would be the interval data, what you want to benchmark against. So this is the base period that you're monitoring. And then you establish the reporting period. And then Wattics creates a model. And it's multivariable, so you can bring in occupancy or hours of operation and cooling and heating degree days and other metrics. And you can pick models for weekends or working days, so you can get fine-tune the calculations. So it's showing what the regression is based on the variables you're bringing into the equation, and then showing the savings. So the red here is the calculated model based on the model you create, and then the green is the measured. And so this would be the base period, and it's just proving out that the calculated, it lines up with the measured, and then you implement your conservation measure, and then it starts reporting the delta between the calculated versus the actual. Down below, it gives you your savings per year, both use and cost, and then gives you your payback period. One of the really nice uses of this tool is once you've identified all of this information, you can then download a very nice presentable report that you can then give to other stakeholders that describes the entire project. And that report looks like this. And you can put your logo and brand it in a way that's tailored for you. And so we walk through, and it's a very nice report showing all the details about the project. Okay. Let me just wrap up with one last slide here about pricing. The way Wattics is priced, it's a subscription model. There's an annual platform fee that starts at $4,200 per year that provides access to the tool and then access to upgrades and our customer success team. There then is a per point fee based on if you're tracking one variable or many variables, generally with electric, if you want to track power quality. There's a per point fee that varies based on how many points you are tracking. So platform fee plus the per point fee gets you your annual fee for the year. So it is priced based on the number of points calculated or metered points. And then the one-time fees are for us to do work to help integrate to your systems. So there's really no setup fees to get going. It's just if we need to develop a new interface to hardware or metering databases, there would be a one-time fee just to get that integration done. We do offer bundled discounts when you're packaging this with EnergyCAP or Carbon Hub or any of our other products. Please get in touch with our sales team. We're happy to talk more with you. If you have questions, contact us, sales@energycap.com. Happy to meet with you individually and talk about your interval data analytics need. Thanks for attending today. Hope you learned a lot. Thanks. Have a good day.